If you're anything like me, then whenever you see a molecule in 3D, you go like, "Yas!" But the chances are you're not like me, and the words like Newman projections or chair conformations or anything to do with stereochemistry makes you want to run away as fast as possible and as far as possible. Well, if that's the case, then this is exactly the video you'll need to watch, because I can promise you that at the end of it, you're going to be drawing the Newman projections like a pro. And the best way to illustrate how to deal with the Newman projections is, of course, with an example. So let's jump into it right away. Well, first of all, we're always going to indicate how exactly we're looking at the molecule. Typically, your instructor will show the eye and the direction in which we're looking at the molecule. Personally, I like to use little stick guys over here. I think it kind of looks a little bit more fun. Alternatively, your instructor might say something like look at carbons 2 and 3 or between carbons 3 and 4 or something like that, indicating which two atoms we need to align in order to make the Newman projection. We're always going to show the front atom as a dot, while the back atom is going to be a large circle with the dot inside. Next, I'm going to add a couple of helper tools to the structure. Those are the plane of paper, which is my blue line, and the horizon, which is my red line. Those are going to be our mental aids. You don't want to be actually drawing those on your Newman projections, but they will help us figure out where exactly the groups are in our molecule. So why do I need those? If I rotate my molecule just a little bit to align the bond we are looking at through the horizon, we're going to have a very clear picture of which groups should be above the horizon and which groups should be below the horizon in the Newman projection, just like so. Now, remember how particular I always am about proper drawing of your dashes and wedges. I'll remind you, we always draw our dashes and wedges away from the point in the bond line structure. So if this is my point, then my dashes and wedges should be right over there. If you draw them on the opposite sides, like this, it brings ambiguity and ultimately may cost you points on the test, as you can easily misinterpret where the groups actually are. Alright, so the next step is to look at our dashes and wedges. The way how we look at the molecule is super important here. If we look at our molecule from left to right, like what I have on this example, then our wedges are going to be on the right side of the paper line in the Newman projection, and likewise the dashes will be on the left. Like this. And if we're looking at our molecule from right to left, it's going to be the other way around. The dashes are going to be on the right, while the wedges are going to be on the left. So now, when you know all the tricks, we can actually go ahead and build our molecule. So first, I'm going to start with the dot. Then the back atom is my circle. Then the OH group is above the horizon, and it's to the right. The hydrogen atom is above the horizon, and it's on the left. The CH3 group is in the plane of paper below the horizon. Now, moving to the back atom, in the back we have the phenyl group, which is in the plane of paper above the horizon. The chlorine atom is below the horizon to the right. And finally, the propyl group is below the horizon and to the left. Just like that. Easy, right? Now, before we look at a few more examples, I want to go over a few variations of the Newman projections that you'll see in your class. We're going to see two versions of the staggered conformation, the one that looks like a peace sign, so this one, and the one that looks like a Y shape, so like that. You'll be making those when you see your molecule making a typical zigzags. So when your molecule is zigzagging around, that is when you are going to be making regular Newman projections in staggered conformations. We'll also see the two versions of the eclipsed conformation. In those conformations, the groups are right behind each other, so drawing them will always be a little bit awkward. So you're going to be kind of squishing them together right next to each other. And since we cannot realistically show two groups one behind the other one, we'll have to offset the back atom just a little bit. Make sure that you are doing it very carefully and your structures are easily distinguishable. if I cannot distinguish your Eclipsed structure from your Staggered structure, I can guarantee your instructor is going to take points from that. You will immediately know that you have an Eclipsed conformation if your molecule looks more like a U shape, something like this or something like that, rather than just a regular zigzag. Alright, so now we are ready for some examples. For each of those examples, pause the video, work on your structure, and then check your answer. The first one is already on the screen, so go! First, I'm going to add my implicit hydrogens so I don't forget to draw them in my Newman projection. Next, this is going to be an eclipsed conformation, so I'm going to draw the corresponding shape for it. Finally, I'm going to add my groups to where they belong. And since it's an eclipsed conformation, drawing the groups is always going to be somewhat awkward, so do your best. We have oxygen and bromine on our bottom right, so below the horizon on the right side. We have both of our implicit hydrogens below the horizon on the left side. We have the methyl group in the plane of paper looking up, and we have this butyl group over here again in the plane of paper looking up over there. Next, how about this molecule? You ready to check it? Your Newman projection should look something like that. Since we're looking from the right side, I'm going to have my dashes, the hydrogen and OH, be on the right side. The corresponding OH is going to be below the horizon, while the hydrogen is going to be above the horizon, just like that. My CH3 group and my ethyl group are in the plane of paper, they're on the plane lines. CH3 is above the horizon, while the ethyl group is below the horizon. Then the aldehyde group from this perspective is going to be on the left side and it is above the horizon. The implicit hydrogen is on the right and above the horizon, and as I've already mentioned, the ethyl group is going to be below the horizon and it's going to be looking straight down in the plane of paper. Well, how about this molecule? You have your structure? Let's check it. This one is also going to be an eclipse conformation like the one on top of this page, so the back atom will have to be hiding its groups right in the background. So I have my line of the horizon, so anything above that line is going to be above my horizon. So the OCH3, my hydrogens, my methyl group, all of those guys are above the horizon. So OCH3 is above the horizon to the right. The methyl group is above the horizon to the left. My hydrogens in the back are hiding right there. And of course I have two more groups in the plane of paper below the horizon looking just like that. So what do you think? Easy? For as long as you follow this algorithm, I can guarantee that you'll make a correct Newman projection every single time with almost no effort. And once you practice a little bit, you'll also be able to do it really fast. And talking of practice, check the links below or visit organicchemistrytutor.com for more practice problems and other tutorials. Tell me your questions and feedback in the comments below, and I'll see you in the next video.